Good afternoon, everyone. I'm Nicole Henderson, Editor-in-Chief at The Word, and I'd like to welcome you to today's webinar. Today's session is called 5 Ways to Improve Your Storage Layer, and it's presented by Boyan Ivanov, CEO and co-founder of StorPool. When Boyan was 10 years old, he started programming. At the same age, he started his first venture, and the ladder stuck. He is a leader on the business side with versatile abilities. His experience spans both the enterprise and SME worlds. He has worked in banking, finance, and M&A. Prior to StorPool, he was part of several startups in the IT space that included an ISP company, online auction, data warehouse consultancy, and a networking company. For the last several years, Boyan has helped companies make a quantum leap in their data storage with StorPool. Before I hand it over to Boyan, I want to let you know that there will be some time for questions at the end of the presentation, but you can ask them throughout the session as well using the question function in the webinar software. You should see a box on the left side of your screen where you can ask questions. If for some reason you can't see that box, there is a red Q&A button at the bottom that will make it appear when you click on it. If you ask a question and it doesn't get answered because we've run out of time, or perhaps it is a bit too specific, somebody will reach out to you by email following the webinar. Finally, there will be a video archive of the webinar available if you want to rewatch the presentation or share it with someone else. It'll be in the archives at theword.com/webinars by the end of the week, so make sure to check that out. You should also get an email with a link to the presentation. Okay, let's get started. Welcome, Boyan. Thanks for joining us today.
Hi, everybody. Thanks, Nicole, for the introduction. I wouldn't want to take any more time, and I would just jump directly into the presentation so we can be as efficient as possible. So today's webinar, 5 ways to improve your storage layer. What are we going to cover today? So we'll start with the current state of storage solutions. We'll go through the pros and cons of each of those solutions. We'll go with a storage list, or what you want from your storage. We'll go to the 5 ways to improve your storage layer, and then we'll wrap up and have a Q&A. So we're going to, if you're building a storage service and you're basically a cloud builder, it doesn't matter if it's public or private cloud. It might be a hosting company, MSP, enterprise. And if you manage your own infrastructure, then you have already figured out that data storage is one of the most expensive and most problematic pieces of pieces in the data center. So, there should be a better way of doing data storage. And for the last couple of years, we have seen a lot of innovation in this space. What we're going to cover today is block storage. So we're going to talk about the block level of storage. We're not going to touch object or file. And basically, block is the base for file or object. You can tip file or object nicely on the block, whereas vice versa, it's not as easy task to do it properly. We'll go through the options that you have, and the first one that you're all familiar with is DAS, or Direct Attached Storage, which is basically servers, standard servers with drives in them, hard drives or SSDs. We'll go through the pros and cons of each of the storage solutions that are currently widespread. We'll go in a bit. So the other option that you have is the SAN, or Storage Area Network. It's basically a specialized piece of storage hardware. We actually have a white paper of the 5 things that storage vendors don't really want you to know. And it covers this, but a sandbox, it's still a big box that holds the drives, but it still has the same things that you find in a standard server. It has CPU, it has RAM, it has hard drives or SSD, so it's basically a very fancy box, or a very fancy server. A while ago, maybe about 10 years ago, some people decided to try and run storage software on standard servers. And this is what we call software-defined storage 1.0 solutions. And there are just a few of them. And lastly, with the rise of SSD media, now we have what's called all-flash arrays. They're basically, again, specialized storage box, but now instead of hard drives, it's filled with SSDs only. And it comes from new type of vendors usually. So what are the advantages or disadvantages of each technology? The first thing with direct attached storage, the good thing is really inexpensive. And a while ago, most hosting companies and service providers were running this way. On the negative side, it's own capabilities, and it doesn't provide shared storage. So we have a number of customers that are sitting on one server, and if something happens to this particular node, then your customers experience downtime, they might lose data. So it's not a good way to have happy customers. The other approach is sandboxes. The good thing about them is they're fast and they have a lot of features. On the negative side, they're really expensive and they have some technical challenges, like they're hard to scale, inflexible, complex, and they're specialized hardware, so they're a form of vendor walk-in. The software-defined storage 1.0 solutions, the good thing is about them is they're affordable. They sit somewhere in between direct attached storage and sandbox. But they're limited in scalability and inflexible. In many cases, you need separate boxes for the storage, and in many cases it grows in pairs. So you cannot just add one server; you have to add two. And the bottom line is these solutions, because of their implementation, they cannot really replace the sandbox. And lastly, we have the all-flash arrays. They are fast and have a lot of features, some of them, but they're still really expensive. They're, in many cases, limited in scalability and, again, a form of vendor walk-in. So this is a resume. If you have all these solutions that are currently available, you can put them in two buckets. Basically, you have in the data center, you have the compute, the networking, and then you either have SAN or flash array, or the other option that you have in the data center to build the service is compute, networking, and then you have separate servers for the storage, and this is the software-defined storage 1.0 approach. And there are a number of disadvantages to these approaches. So, what you really want from a storage system is something that's a system that's reliable, and we call this a feature zero, because in many cases nobody really talks about it, but this is something that you absolutely want from a storage system. And some systems are better than other systems in the level of reliability that they deliver. You want this system to be with high performance, and still you want it to be scalable and flexible. So you want your storage system to adjust to your business needs and not the other way around. You want this system to be simple, and simple all the way, from buying to deploying to managing to upgrading and growing. And lastly, you want it to be affordable. And it's a well-known fact that for any $1 that you usually spend on virtualization, you spend $5 on specialized storage box. So storage is really, really expensive nowadays. And what if there is a better way to do data storage, and you can have all these 5 advantages like reliability, flexibility, scalability, or cost in one solution? And in our view, you have to run standard servers and have the storage and compute in the same nodes. And this is a trend that lately has become popular as converged infrastructure, or in some cases, hyper-convergence. In some cases, you even move the network inside the same node. And then you have intelligent software that runs on the same servers and provides storage. So we have one building block for the data center. The magic about it, that this software really has to work, and this is something that's not really available today. And this is the software-defined storage 2.0 concept. And we'll cover each of the factors that, the 5 ways that you can improve your storage layer. And a note here, we think that you can build all the intelligence into the software layer, but even if you're using some form of other storage solutions, we'll still cover some ways in which you can improve your storage, whatever you're using. So you can get something, no matter what the storage is, you can still get something out of this webinar. So the reliability. A lot of the right concepts were thought of some time ago, and they're already implemented into the hyperscale infrastructure. And companies like Google, they work this way. And we see small service providers are now looking to adopt these technologies, and they're going also into the enterprises. So the concept is simple. It runs on standard hardware. All the magic is in the software layer. It has to provide shared storage in order to have really reliable service. And it runs on many cheap components. So the idea of having one super reliable component, it just doesn't work at scale, because the cost of doing one component really reliable grows exponentially. So you really want to have several small components that are cheap and replaceable. You don't want single, or in case of most storage boxes today, dual points of failure. They have 2 power supplies, 2 network controllers, etc. Then with the growth of data, with the explosion in the data sets, you need something that really protects data. And before we had, you might have read about things in the research papers like phantom writes, misplaced writes. You give something to the hard disk, the disk says, I've written that information, but it hasn't. So these are things that become really common in today's environment. You want a system that's intelligent and self-healing and can grow, and it can make even small things, like we have an example here with copies in different servers or in different racks. You don't think about the single box anymore. You start to think on a larger scale, on a rack base, and you want a new level of flexibility. So what can you do to improve your storage layer here in terms of reliability? Well, a lot of it comes into preparation and design phase. So you really have to take precaution. You have to have procedure in place. You have to have what ifs when you design your system. What if the system fails? And if there is a storage vendor that tells you that their system is 100% never going to fail, that's not true. Unfortunately, in the real life, everything can fail, and at some point it will. So we really have to have procedures and have design of the system that says, okay, what if this fails? What am I going to do? How I'm going to react in this case? So another thing that you can do is to burn in the hardware that you get. We see a lot of vendors that send hardware, storage boxes or servers or whatever it is, that is not tested before it goes into the data center. For example, we make a very thorough 24-hour burn-in test, very intense on any hardware that we get. And we find faulty hard drives and faulty SSDs and faulty RAM, even though they're brand new. And especially with some SSDs, unless you rewrite them several times, they're not conditioned, so you cannot get the native performance out of the drive. So you really want to burn in anything that you get into a data center. A good thing is to have fire drills. So just because you had a good process or good design of your system 6 months ago, it doesn't mean that it's now working as it was designed to do. So you have changed firmwares, maybe you added new hardware, your workload might have changed. So you really need to test every once in a while to make sure that your systems are working as expected. Another thing here is backup and disaster recovery. And you're thinking, oh boy, this is so basic, but you would be surprised how many companies are actually not having a proper backup system or disaster recovery plan. Everybody knows that they should have one, but for some reasons it might not be working, or in many cases, they haven't followed the previous steps that are very applicable to a primary storage, but they're also applicable to a backup. So you have to design it well, you have to burn in, then you have to make guardrails on it as well. In terms of performance, performance is something of how fast your system should be. And there is not a rule for that. It depends on your use case, depends on the business, on your goals. So you really have to test what is the desired level of performance for the system. And a thing that we say, you really have to make a log of your actual workload and then test with that. We've seen a lot of customers that come to us and say, like, I need 100,000 IOs out of the storage system. And we benchmark it, and their existing system maybe is peaking at 10,000 IOs. So it's a good plan for the future, but in many cases, companies don't have a very good idea of what they actually need. And the thing with synthetic tests of giving you some indication about the performance of a storage system, it's very misleading. You can be way off with this prediction. So we really recommend having a log of your actual workload, replay that log. It's a misconception that it's hard to gather such a log. It's not that hard, but it will give you a very good understanding of what your new storage system is going to deliver for your particular workload. So you want a system that scales in performance, not only in capacity. And in many cases, like you have a sandbox, it's limited usually by the controllers that are in this box. So they become the bottleneck. And no matter how many drives you add only capacity, but you don't add performance. Ideally, you want a system that can scale with small increments linearly. It can go, scale IOs or whatever measure you use for performance, be it throughput, and it scales in capacity. You want a system that doesn't have bottlenecks. So it's not a system, again with a SAN example, it's not a system that you go to a vendor and they said, oh, just buy a new box, because that's a throw money at the problem solution, and it's not really a solution that's recommended. On the performance side, if you're looking into software-defined storage solutions, then you should be looking how efficient this software is. Can it really run storage and compute on the same nodes? How much resources it takes out of each node? So this is also a measure of performance and efficiency for the storage system. You want fast rebuild. That's also something related to a thing we said earlier. If you have a system that fails for whatever reason, how fast the system is going to rebuild. For example, we had a customer that came to us with a very specific requirement about the speed that they want for their recovery of their system. So that really helps your storage vendor. If you go with a very particular requirement, that's really a help to the vendor to give you a good solution. And the performance thing, there is no free lunch here. You usually trade one feature for another. So if you have a lot of performance, then it's very, maybe you're trading off capacity. We see a lot of people and a lot of marketing lately pushing concepts like dedupe or deduplication, but dedupe is not a free feature. So it saves capacity, but it taxes heavily the CPU and the RAM of the system. So it basically, it costs performance. What can you do to improve your storage layer in terms of performance? First thing is diagnose where the actual problem is. You might think it's the network, but it might turn out that you run IOs, you hit the bottleneck of the drives themselves. You might have hard drives that are not pushing enough IO. Another thing is, you can solve some of the performance issues with software features. And this is features like caching or hybrid clusters, something that we do in StorPool that makes copies of data on hard drives and or SSDs. And it gives you performance that's almost all SSD array performance at a much lower cost because a lot of the media inside is hard drives. But it's, again, a software feature that can do a lot to improve your performance. And the other thing is kind of trivial, but in many cases it's related to the first point. If you find where the bottleneck is, then you can upgrade some of the components of your storage system, like network, or you add SSDs, etc., and you can solve some of the performance issues there. In terms of scalability and flexibility, you want a system that scales out, not scale up. So you don't want to replace one big box with another bigger box and have the forklift enter the data center. You want a system that can scale really smoothly in terms of capacity and performance and money as well. And a good software-defined storage solution can scale with just adding a single drive or a single server. And this is something that really helps a service provider to have flexibility in the way they operate their business. Another small things that relate to the intelligence of your storage layer are the way or the degree to which this system is flexible. So can you just take the drives from a failed node and just put them in another node, power it on, and the system continues working, rebuilds only the deltas of the missing data? This is a level of scalability and flexibility that saves you time and reduces your downtime. You have happier customers. Another thing that we see with a lot of systems is they don't really have the flexibility that your technical teams in your day-to-day operations of the storage layer. So they cannot expand online volumes and file systems and bulk devices. And this is something that you absolutely need in the cloud era. You want also the software or the storage layer to be able to update or upgrade online without stopping your service. And this is something small, but again helps a lot into the customer experience that your customers are getting. And in many cases, or in almost all cases, this is intelligence that's built in the software. Even if you're using a standard specialized storage array, this is usually a feature that comes in the software layer. And in many cases, they cost additional. They come at a separate price tag, but I guess this is the way it is. What can you do to improve your scalability and flexibility? A lot of it is preventive. So you have to research and plan what your system has to be, what you want out of the system, what are the levels of SLAs that you want to give, and what are the things that you want your customers to be able to do with your system. So here it helps if you can write them down and just go with them to your vendor and really have something tangible to show. I want this, I want that, like a checklist. Again, you can go and find a particular bottleneck, as in the case with performance. So in many cases, you can improve, you can make some gradual changes into your system and have a better scalability. And unfortunately, at some cases, you might have to throw money at the problem. So in some cases, you're stuck with your current storage solution that's not really flexible or scalable. In this case, you just have to look for something that can give you the levels of scalability and flexibility that you're looking for. Simplicity, that's a big thing for storage. So you want a system that's really designed to be simple, and simple all the way. You want a system that's simple to buy, simple to deploy, operate, expand, and support. And we experience this really a lot with companies that come to us and they complain. They said we had 5 meetings with the sales reps and technical teams of big storage vendor, and we still cannot get a price quote, at least a range, like a price range. And you don't want that. You want a solution that's transparent, that's simple, and when you have to expand it's a straightforward process. Obviously, this is running on standard hardware, or if it's as standard as possible, it's easier to get it. And if you have standard servers, standard drive, standard network, it's obviously much simpler to support a standard Ethernet network rather than a fiber channel. Like the people that can support standard network are much more than the people that can support fiber channel, for example. You want a standard building block that simplifies the data center that you have. So if you have just one building block, it's simpler than managing 3 pieces of storage, networking, and servers separately. You want a storage solution that ideally is hardware agnostic. So you want a solution that you can have all the intelligence in the software layer, and you can have like a commodity river, a river of commodity hardware underneath. So you can mix and match different vendors, and you can replace hardware without any disruption to the service. And you want this system to be intelligent. So the more intelligent the system is, the simpler it is to manage. For example, with a good storage software, if you lose a drive, you can just relax. In a typical scenario, if you're using a RAID system that usually has drives that are mirrored, and you lose one drive, then you have to run over to the server, put exactly the same drive as size and capacity and type, and then wait for the rebuild operation. If you have an intelligent system, you don't have to do anything. As long as you have capacity, the system will rebuild and comply with the desired level of reliability of the system or redundancy. And again, the simplicity, I've touched this already, but if you have standard stacks or hardware, you don't require somebody who's certified in a particular technology, which makes it easier to operate and simpler and more cost efficient to operate a service provider this way. And this all comes down to having a system that's designed with you in mind. So in many cases, you just open the price list of a big storage vendor, and it's hundreds of pages. We have this touched in our white paper, the 5 things storage vendor don't want you to know. But in many cases, you have one component that's listed there several times, and you have to go and see what's the difference and why should I buy this and not that, and they have different price tags, and it's designed to be complex and for a reason. But you don't really want that. You have plenty of other things to look after. So what can you do here? It's choose carefully. When you have to upgrade your system, or if you're starting a new project, then you really have to look at system that can deliver on the simplicity. It has to be simple, it has to be standard. So the more standard it is, the more you avoid vendor lock-in, the better. A thing that can help you if you're stuck with your current storage system, or you're just investing in it and you are not going to throw it out and buy something new, a small hack that you can make here is automate. It will at least remove some of the day-to-day hassles that you have, and it will reduce the complexity and the time and effort that's put into managing the system into day-to-day. And on the affordability front, if you're running standard hardware has many advantages. It's the reason why hyperscale giants are running on standard commodity hardware. It's the reason why virtualization runs on x86 platform, because it's much cheaper to get it, it's simpler to get it, it's faster to get it. You can get it literally just behind the corner. It requires standard skill set, so you're looking for the amount of money that you're going to spend on specialized skill set. And especially with the current IT jobs market, it's really hard to get some skills. The more specialized the skill, the more expensive, but also the harder to get it. On the affordability side, you have storage and compute into the same system. You can have higher utilization, and thus lower the total cost of ownership. And it goes through the whole data center. You need less footprint into the data center, you need less cooling, less power, you need less ports on the networking side. It basically reduces your entire data center bill. It has impact not only on the storage layer, it also impacts the whole service. Another thing that we see is that you want storage to be priced, if possible, on a pay-as-you-go basis. Especially in the service provider segment, where there are cash flow driven businesses, you want storage that follows your current needs, so you can scale up and down, and it really is a driver for adoption of storage software solutions. So the affordability thing, unfortunately, if you're not having an affordable system, there is not a lot you can do. So again, in many cases, you have to trade off, or at least before you had to trade between high performance and low cost. And now it's not the case anymore, but in many cases, you cannot really do something. And here we have a note. We talked to a vendor, to a service provider that said, okay, I'll just sell some of this stuff on eBay. A thing that you can do to improve the affordability for storage layer is to play with features. So let's say you want to have a lower price on your storage layer per gigabyte. So dollars per gigabyte is what you're after. And in this case, you can employ data reduction features, like it could be compression, it could be team provisioning, snapshots and clones. There are many technologies that can reduce the footprint of the data. So in this case, you can improve the cost of your solution by getting some new features. Of course, they might not be free, but then you look into the business case. And in some cases, if you're stuck with a solution that's not really as efficient as your cloud operations need, then you might consider buying a new storage solution. And we had a case with a customer that said, we just invested in a big storage array, and funny enough, for their particular case, it doesn't even deliver what they were promised to deliver. So now they have this dilemma of what should they do? Should they keep it, or should they have some small investment and try something new? So in some cases, you might not have a lot of options there. And as a recap of the things you can do, no matter what you're using today and what your situation is, there is still something that you can do to improve your storage. It could be features, it could be getting some external help, it could be getting somebody as a consultant to improve something, it could be changing a vendor, there is still something that you can do about it. Thing that we believe something that's happening as we speak, and is the way for the future, is having intelligent storage software, and it can have all these things in one solution. But it's something that you either need it as of today or not, or if you've invested some cash into your current storage solution, you might need some time to adopt something new. And I highly recommend you to have a look at a white paper that's on our website. It can give you some additional ideas on what to look for when buying storage solutions. It will help you and guide you through the buying process, because it sometimes is very complex and really tricky. So we really hope this is something that will help you to get a better storage. And with this, I would like to go into the Q&A session, if there are any questions.
Okay, great. Thanks a lot, Boyan. So just a reminder, if you would like to ask a question, you can use the Q&A button at the bottom, and a box will pop up that will enable you to ask questions. For now, we've got a few questions here, so I'll ask Boyan. The first question we've got is, there are a number of software-defined storage solutions. Which one works best?
Okay, that's an interesting question. So I think there is not one right answer here. So depending on your use case, on what you're trying to achieve, so what are your objectives, what is your workload, you have to really look into the options that you have. And I firmly believe that there is not one solution that's really good at everything. Like, you cannot expect a truck to be a proper racing car. And with this in mind, you have to look into the solutions and which one fits best to your needs. I think this is something that maybe select 2 or maybe 3 and then test them and see which one works best for you.
Okay, great. So the second question I've got here is, how hard is it to migrate to an SDS, or software-defined storage solution?
That's also a good question. So what we see in many cases, companies adopt software-defined storage solutions when they spin a new service, like they go greenfield, so they start afresh or new. Or the other option is they go to their traditional storage vendor and they ask for additional storage or to buy more. And they were given a good discount on their first purchase, but now they're not getting such a good price. And this is a reason why a lot of companies this is when the companies start looking for alternatives. And then adopting a software-defined storage solution, if it's properly built, it's kind of straightforward. You can buy at least 3 servers. They could be standard servers that cost maybe $2,000 a piece. So you have $6,000 for the nodes. You have network, a proper 10 gigabit Ethernet switch nowadays you can get for $6,000. So you have like $10,000 for the initial investment, and drives that as much as you need. But you can start really with a low investment and then grow it. And the process itself, it's rather straightforward itself. I mean, you can easily test the solution, make a POC in 2-3 weeks, and then test it a bit more and deploy it in production. I mean, it's pretty straightforward, and it can be a fast and simple process.
Okay, great. So the next question I've got here is, does any standard hardware work with software-defined storage solutions?
Well, in theory, yes. In practice, any vendor has system requirements list. And in some cases, what we experience is some hardware just works better than other hardware. For example, we've experienced SSDs and some SSDs that they're all enterprise class SSDs from the same class, obviously. And some SSDs just work way better than others. And you might encounter problems with drives, with network cards, with switches. It's rarely the case with switches, but with some hardware, you might experience problems. So you basically have to test. And the good thing about standard hardware, that it's cheap and it's easy to replace. So let's say you have an SSD that doesn't work well with your software-defined storage of choice, then you can easily get a new drive, a sample to test, and then switch the SSD to something that really works well. So that's kind of like a small issue, but you still have to kind of pick and test your hardware before you put it in production. Okay, great.
So that appears to be all the questions we've got for today. Just a reminder, if you do have any follow-up questions after the presentation, there's some information on the slide that's up right now to contact Boyan or to contact StorPool. So you can email either bi@storpool.com or info@storpool.com. And you can also contact them on Twitter, and the Twitter handles are there, as well as go to their website, www.storpool.com. www.storpool.com. So that's about all the time we've got left for today. I'd like to thank everyone for attending and for submitting the questions. I'd also like to thank StorPool and Boyan for the presentation today. Thanks again, everyone, and have a great day.
Thank you.